Hello students, in this video we will see Lagrange's method of interpolation. So the method of estimating the value of function at any intermediate value of the independent variable when its values are known only at certain specific points is called as interpolation. So it's like we have discrete data where x is independent variable and y is dependent variable, and for some finite values of x we know corresponding values of y. Okay, so this interpolation helps us apart from these finite values. If you take any value between the lower limit and upper limit in this data for x, the corresponding value of y we can find using interpolation. So that is what interpolation is. And if you used to find a value of y corresponding to value of x which lies outside these given finite values, then that is called as extrapolation. So in this video we will see Lagrange's interpolation. So here we have to find a polynomial which fits given data. So suppose we have this simple example, let y as a function of x such that at x is equal to 1, value of function y is 3. This is the only condition. X is equal to 1 and y is equal to 3. That means when input is 1, output is 3. So we can find the simplest function, which is this. Y is equal to f of x is equal to 3. This is the simplest function we can have. You can see here, when you put x is equal to 1, output has to be 3. Even for any value of x, output is 3. But it fits our given data, right? Okay, so this is a simple example. Let's go to a slightly complicated example. Suppose we have this y as a function of x such that x, for values of x equal to 1 and 3, values of y are 4 and 5 respectively. That means when we give input as 3, output must be 4, and when input is 3, output must be 5. Now how will you find a function or a polynomial? Okay, basically we are going to find polynomial function. So how will you find a polynomial which fits given data? That means when you put x is equal to 1, y should take value 4, and when x is equal to 3, y should take value 5. Now we cannot have such constant function, right? Because we don't have constant output. So what we can do here, okay, so look at this. Y is equal to f of x is equal to x minus 3 upon 1 minus 3 into 4 plus x minus 1 upon 3 minus 1 into 5. Okay, so look at this example here, or this function here. So when you put x is equal to 1, see what's happened. When you put x is equal to 1, this second term will become 0, right? Because it will get, in the numerator will get 1 minus 1, which is 0. And in the first term, what happens when you put x is equal to 1? This numerator matches with denominator, so therefore it will get cancelled and we'll get answer as 4. Similarly, when you put x is equal to 3, what will happen? This will become 3 minus 3, 0. So first term will vanish, and in second term we'll get 3 minus 1 upon 3 minus 1, that is 1. So answer is 5. So this is a technique here. Okay. So this first term you have to design, such that when you put value of x is equal to 1, value of x is equal to other than 1, this term should vanish. Alright. And when you put x is equal to 1, all other terms, okay, except this first one, all other terms should vanish like this. So when you are putting x is equal to 1, you can see second term vanishes. When you put x is equal to 3, first term vanishes. Okay, and the one more condition is when you put x is equal to 1, this numerator upon denominator should be equal. So that we will get 1 here, and we can put this output value that we want here, which is 4. So this is how this function is designed. Okay, so you can check here, when you put x is equal to 1, it gives value. What this will give us? So this will vanish and answer will be 4. And when we put x is equal to 3, so this term will vanish and we'll get answer as 5, because 3 minus 1 upon 3 minus 1 will be 1, and answer is 5. So this is a technique we are going to use, and this is what a Lagrange's interpolation is. So let's see, for given big data, how will you find the Lagrange's polynomial? Suppose we have these outputs: y takes values y0 to yn, okay, for corresponding values of x which are x0 to xn. Okay, not necessary equally spaced. These values may be, so it is not compulsory that all these values are equally spaced. Okay, so you will require this when we study Newton's forward and Newton's backward methods. There we want equally spaced values, but for Lagrange's interpolation it is not necessary. So we have to find a function or a polynomial function which fits given data. That means we have to find a polynomial such that when you put x is equal to x0, answer should be y0. When you put x is equal to x1, when input is x1, output must be y1, like this. So the polynomial is this: f of x is equal to this. Now look at here. Look at the first term. We have to design this first term, okay, this numerator upon denominator. Okay, forget about this f of x0. This term, such that when we put x is equal to x0, it should be 1. Right, now look at here. When you put x is equal to x0, what will happen? x0 minus x1, x0 minus x2, x0 minus x1 upon x0 minus x1, x0 minus x2, x0 minus xn. Okay, everything is same, so it will get cancelled, you get 1. Okay, and when you put value of x other than x0, the first term should vanish. It should become 0. You can check it here. When you put x is equal to x1, the first term will be 0 and therefore everything will become 0. If you put x is equal to x2, second term will be 0 and everything will become 0 then. Alright, so what happens here, when you put x is equal to x0, this whole thing becomes 1. Okay, here f of x0, that means the output that we want, right, plus, so plus, now you can see when you put x is equal to x0, these all other terms will vanish because all these terms are also designed with same fashion. When you put x is equal to x0 here, you get x0 minus x0, which becomes 0 for every term. For this last term also x0 minus x0, 0. Okay, so everything vanishes. So we left with only this first term and this numerator upon denominator, so it will become 1, and this f of x0, that is what the output we want, right? So we will put y0 here. So this is what the Lagrange's interpolation polynomial is. You can see here in the first term we have excluded x minus x0. Okay, look at the values in numerator, and in denominator, in place of x only, we have replaced that by x0 into y0. Plus for the second term, what we have done, we have excluded one term, which is x minus x1. Right, look at here, x minus x0, then x minus x2 up to x minus xn, and in denominator just replace x by x1. So x1 minus x0, x1 minus x2, x1 minus xn, and into y1, so that when you put x is equal to x1, when only this term will survive, all other terms will become 0, and even this term will become 1. Okay, so output will be y1. So similarly, we have to form all other terms. So this is what Lagrange's interpolation formula is. This gives us, for n terms, it will give us polynomial of degree n minus 1. Alright, right now there are n plus 1 terms here. Okay, first term is x0, last term is xn. Okay, so n minus 1 term. So this y is equal to f of x, this will be nth degree polynomial. Alright, so let us solve some examples on this. So here we have to find the velocity of the vehicle when time is 2 hours. Also find the distance moved by a vehicle and its acceleration at the end of 4 hours if the time versus velocity data is given as follow. Okay, so this is what is given. When time is equal to 0, velocity is 20 kilometers per hour. When time is 1 hour, velocity is 25 kilometers per hour. When time is 3, velocity is 33 kilometers per hour. When time is 4 hours, velocity is 27 kilometers per hour. Now what do we have to find? We have to find what is the velocity when time is 2 hours. Okay, so our answer maybe it is between 25 to 33. Okay, so let's see how to find it. That is first part of our question. You have to find a velocity when time is 2 hours. So this is a question of interpolation, right? Because you are finding value of y for values of x between 0 and 4. Therefore, it is interpolation. So we will use Lagrange's interpolation. So this is our formula now. Now see, t is our independent variable and v is a dependent variable, right? So t is nothing but x and v is nothing but y. So Lagrange's interpolation formula is this. So there will be 4 terms because there are 4 inputs, right? There are 4 terms in this formula. So t minus t1, we are excluding first t0, right? T minus t1, t minus t2, t minus t3 divided by t0 minus t1, t0 minus t2, t0 minus t3 into the output that we want for first term, v0. Similarly, plus t minus t0, and now we are excluding this term, okay? T minus t1 we are excluding. We're directly going for t minus t2, t minus t3. Okay, in denominator just replace t by t1, t1 minus t0, t1 minus t2, t1 minus t3 into output for t1, which is v1. Okay, similarly these next two terms, now put values. So we know that t1 is 1, t2 is 3 and t3 is 4, right? t1 is 1, t2 is 3, t3 is 4, like this. So put all these values. v0 is 20, v1 is 25, v2 is 33 and v3 is 27. So put all these values and after opening these brackets we'll get this polynomial. So v is, see, we got third degree polynomial because there are 4 values, okay, 4 inputs and 4 outputs. So you got third degree polynomial, minus 3 by 4 t cube plus 8 by 3 t square plus 37 by 12 t plus 20. You can check this, thus this polynomial fits given data. You put any value of t from these 4 values, you will get corresponding value of v. For example, if you put x is equal to 0, let's see what happens. This term will become 0, this will be 0, this will be 0, output is 20. Okay, similarly you can check for all other 3 values also. Now, so we got Lagrange's interpolation formula. Now next aim is what you have to find what is the velocity when t is equal to 2 hours. So simply just we have to replace t by 2. So we get velocity as 30.83 km per hour. So this is the velocity at 2 hours. Okay, and you can see it is between 25 and 33. So the first part is over. Now we got velocity. Okay, the second part is what you have to find a distance moved by a vehicle and its acceleration at the end of 4 hours. So first is what you have to find a distance moved by a vehicle in 4 hours, in these 4 hours. Okay, so what is the total distance moved covered by a vehicle in 4 hours, that you have to find with these given velocities. Alright, so we know that. So this is our v. Alright, to find a distance moved by a vehicle in 4 hours, we will use integration, right? We know that dx by dt is equal to velocity, right? Rate of change of displacement with respect to time is velocity. Now our aim is to find x. What is the distance, or s? Okay, sometimes we may use x or s as a notation symbol for displacement or distance. So s will be integration. You have to find distance in 4 hours. That means from t is equal to 0 to t is equal to 4. So integration from 0 to 4 v dt. So now put value of v. So after integration we will get 113.555 kilometers. So this is the distance traveled by the vehicle in these 4 hours with these velocities. Alright, so this is how we can find this distance moved by a vehicle in 4 hours. Suppose you want to find distance moved by a vehicle from 1 hour to 4 hour. In that case we will integrate it with limits 1 to 4 and we will get corresponding the required answer. This is the second part of the question. Now third part is you have to find acceleration at the end of 4 hours. Alright, so what is the acceleration? It is dv by dt, rate of change of velocity with respect to time. So to find acceleration at the end of 4 hours, right? So first we will find dv by dt. which is this minus 9 by 4 t square plus 16 by 3 t plus 37 by 12. At the 4 hours we have to find acceleration, so simply put t is equal to 4 and we get answer as minus 11.58 kilometers per hour square. So this is what acceleration is at the end of 4 hours, and it is negative because it is a deceleration. Look at the velocities here, velocity is decreasing, right? So that means at the end there is a deceleration. Okay, so it is minus 11.58 kilometers per hour square. This is how we can make use of Lagrange's interpolation. This gives us a very nice function, polynomial function which fits given data, and even you can use that to find integration and derivative also. Okay, I hope you understood this. Try to solve some more examples on this because this is very important topic. Thank you.